Guys, and today we'll be studying the periodic table. I did say this would be coming in the last video, and if you haven't, go watch that. I will leave a link in the description box below. And yeah, let's get into it. Hey guys, and today we'll be studying the periodic table. As you can see, I have a picture of the periodic table on my screen right now. And first, and probably the most important thing, is you're wondering what are these letters right here? And that is a valid question. These letters are just the elements. So C stands for this C right here. It stands for carbon. This N, I don't know if you can see it. You might want to zoom in or something. But this says nitrogen right under the name. I might actually size this up. So like if I see, look at this. I don't know if you can see it. It's a little blurry, but this is nitrogen. This is oxygen right under here. You should change my pointer to a different color. Oxygen down here. Then you have carbon down up here. Yeah, it's pretty bloody. I'm sorry, but you can view this on the internet and follow along if you want to. Just scale this back down. There you go. This is a perfect size. Okay, might be a little tilted now. There you go. There you go. That's good. That's good. Okay. So, as you can see, we have all the names and all that. And you might be wondering, what are these numbers on top of this? On top of the elements? And that is just the atomic number. And as I told you in the last video, maybe you don't remember, and that is okay, but the atomic number is just the number of protons in an atom. So if you take a boron, for example, this has 5 protons because its atomic number is 5 right here. It's right there. And so like if I took the atomic number, someone asked you the atomic number of carbon, this would be 6. Nitrogen is 7. And yeah. So yeah, that is the number on top. And might be wondering, what is that number on the bottom? What is that number on the bottom? Well, that is the average atomic mass. This number right under here is the average atomic mass. And let's see what that is. So, well, once people learned about atoms, you would have wanted to learn about okay, I need some units of measurement here. And some people created the atomic mass unit. The atomic mass unit. So people created that, and it would just be written as an AMU. And more recently, some people made another a more recent version of this called the unified atomic mass unit, and this would just be represented as a U. And yeah, so now that we have some units of mass in terms of the atomic level, we can measure a proton. So one proton is approximately one unified atomic mass unit. and a neutron. I think I spelled that wrong. Yeah, I spelled that wrong, whatever. So one neutron is going to be approximately equal to 1 unified atomic mass unit. And a proton, it's more close, it's like 1.007 approximately unified atomic mass units, and a neutron is even more. It's just like 1.0000008 atomic mass units, and an electron is about like 1/2000th of a neutron or a proton, and that's a lot. I mean, that's very, very little. It's very small compared to a proton or a neutron. So if you took hydrogen right here, if you took hydrogen, this would have one proton. Like, let's figure out the atomic mass of here. So we have one proton, and most hydrogen in the world has 0 neutrons. And it also has one neutron. One electron if it's a neutral atom. So this is most of the carbon in the world. And if you wanted to approximate the average atomic mass of this, I mean not the average atomic mass, like in terms of atomic mass units, unified atomic mass units, you'd probably get about 1, because an electron's mass is so small compared to a proton. It would be probably about 1 unified atomic mass unit. But if you wanted to be more exact, you could get like, okay, a proton, that would be closer, just a little closer to 1.008. And actually, that is what you see right here on the periodic table. You see 1.0078. But that, even though that's what it says, that's not the number it's referring to. That 1.0078, that is a weighted average of all the various versions, or isotopes you could call them, of hydrogen. So let's say you had an element which 80% of it in the world had the mass of 5 atomic mass units, and 20% of it had a mass of 6 atomic mass units. You would take a weighted average of these two, and you would come with 5.2 as a weighted average. And this 1.0078, that is a weighted average of the versions, or I should start using the word isotopes of hydrogen, and that's a weighted average. Let me minimize. Let me make this thing smaller so you can see it. There you go. No, it's too big. It's tilted. There we go. Okay. Oops, I just realized I forgot this plus sign. So you would take the weighted average, and like if you took beryllium right here, you took the weighted average of the isotopes, and you would end up with an average rate, the average atomic mass. And so that's what that number at the bottom is. And you might be wondering, okay, what are these? What are these? Well, if I wanted to zoom in on this, you would see this one right here says alkali metals. This one right here says alkaline earths. This is transition metals. This is basic metals, and so on. If you want to read it here, you can pause the video. I'm going through it slowly. And yeah, so these things at the bottom, it is color coded. Thankfully, that's why I chose this one to put inside the video. Those are the groups. like the groups of the periodic table, and I decided that would take too long, so I am going to introduce I'm going to talk about all the groups in a next video. Not the next video, but maybe sometime soon. It should take it would take a little bit long to introduce it in this video. So these are just like the groups of what the periodic table is grouped in. These elements, these are all in different groups, and these are the groups down here. And you might be wondering, why are these down here? Why aren't they down here? Because frankly, these rows, they represent like electron types. So like these rows right here, they're like these rows have electron types. So like this row is one type, this column is one type, this column is one type, this column, this column, this column, this column, and so on. They all have like the same kind of like type of energy, of electron configurations and all that. I'll talk about that in a different video, because again, that would make this video a bit too long, and I don't want to bore you guys to death. So yeah. Anyway, that's it for today. If you have any questions, please leave it in the comments down below. And hey guys, hope you liked the video. And today we did study the periodic table. I used Explain Everything to record this video, and yeah, leave in any video ideas in the comments below. And yeah, peace.